Hello, welcome to this video, which is more or less now defining the finite element based on the previously defined uh, discrete, semi-discrete representation of the weak formulation, where we already have the domain chopped up into parts, pieces, and we have now the functions in the discrete form. We can define a finite element ansatz based on the respective Sobolev space we already defined before, and in our case in the H1 it's now a sum over nodal finite elements. So we define a nodal finite element, and there we can also define basis functions which are known and are a sum over all nodes. And these basis functions represent an approximation of the acoustic pressure. And it also can be shown that it converges to the real solution and so on and so forth, which is more the mathematical part of doing finite elements. But in the sense, if we now approximate the acoustic pressure by this approximate variable, which is a span or a sum over nodal basis function and some unknown coefficients, we know the nodal basis function, but we don't know the coefficients, which are the model or the physical solution of the variable. And so the physical solution we would like to model, and then we are trying to solve the system of equation for to get the solution and then get some physical insight in what we're actually modeling. This was now how the finite element ansatz enters the discrete weak formulation, and in the next video I will then show you how the semi-discrete form of the weak formulation looks like.